Hi, and welcome to the Unreal Engine News and Community Spotlight. So first of all, we have a wonderful article celebrating an Unreal 2017. If you didn't catch our live stream on December 21st with Tim Sweeney and Joe Kreiner, you should definitely check that out. And Daniel did a wonderful write-up of all the things that we had going on last year with numerous events. We were at E3, PSX, Gamescom, all the outstanding games that came out and were released last year. If you missed any of that, it's all well documented and definitely well worth a read. Additionally, we had a number of devs in IndieDB's top 100 of 2017, including titles like Absolver, A Hat in Time, Goblins of Elderstone, Islands of Nine. We had over 20 entries, and so we're really proud of the Unreal Engine development community and just all the great work that they do. So rock on, guys. Additionally, we have a couple of multiplayer courses available. So Sam Patuzzi did a Getting Started with Unreal Engine multiplayer in C++. He has a nice introductory tutorial on our blog, and then he has an additional course that you can go check out and really dive a little deeper into multiplayer. We also have a course published by Tom Lumen that is a create multiplayer games with C++. It's a UE4 mastery course. So that's C++ and blueprints for games with AI elements. And that's a wonderful course. It's discounted right now on Udemy. Definitely recommend going and checking both of those out. So this week's top karma earners. These folks are always jumping on, helping their partners or their community members by answering questions and jumping in, and we really love and appreciate that, so I want to give you guys a huge shout out. So there's Zlarator, JinVE, VizJin, EveryNun, Shadow River, Dartanla, FluFlu111, Maki Girl, VR Marco, and Evil Fishy. You guys are amazing, and thank you so much for all that you do for us. On to our weekly spotlight, our community spotlight. So the first project we have this week is a project called Revulsion. So it's a classic first-person shooter roguelite. It's available on Steam Early Access. Has very much that fun, like Doom, retro Doom feel. You know, you're going around shooting these awesome monsters. And so it's by a user named Castle, and he's got a lot of progress and walkthrough. He's got a couple different episodes, and just really excited to see the game progress and what he's working through. And it looks like a lot of fun, and I'm excited to give it a shot. Our second community spotlight is a project called Future Mine. So Dennis Rutkovsky developed this scene, and he just made this really beautiful futuristic environment. He has a number, if you go to the ArtStation page, he has a number of 360 screens that you can actually look around and check out this futuristic mine. The textures are amazing, the models look really wonderful. I love the lighting, and it just, he did a really great job putting it all together, and I look forward to seeing more from him. Our third and final community spotlight, it's a project called Tooki. They just released in December, and it's a fun little puzzler game. This guy, he's an average type of guy who likes having a few carrot beers and playing video games. And he receives a stress call from his TV, and it's Elena, an advanced alien bunny, and she needs your help. And you come through and you're going through solving these puzzles. It's a fun, quirky, I love the environment and the design, and the puzzles look really interesting and challenging. And they've got a lot going on here. I think there's 125 puzzles. There's 5 different levels and beautiful worlds, so really looking forward to seeing this, and it's just fun, guys. All right, thanks for joining our news and community spotlight. Hey all, welcome to the Unreal Engine live stream. I'm your host, Amanda Bott, and with me today I have Tom Shannon, one of our technical artists on the education team, and senior technical writer Sam Diter, which you are all very familiar with. So before we dive in, I wanted to give a warm welcome to Tom. You've recently joined Epic,
Yeah,
and
thank you.
tell them a little about what you've worked on.
Oh my. Well, I've been in the games and visualization industries for the last over a decade.
Mm-hmm.
I've been using Unreal 3 and 4 for 8 or 9 years. I recently wrote a book on using Unreal for design visualization, and now
Nice.
I'm working at Epic Games.
Yeah.
Woohoo.
Where can we get your book from?
You can get your book at all major online retailers, Amazon, and Pearson Books directly.
It sounds like you've said that a few times.
Or at my website.
Awesome. So, again, welcome.
Thank you.
And thank you so much for joining us. So today you're going to go over post-processing a little bit, do some introduction or introductory,
A little bit. Just kinda
and
help
dive
people
into.
get into using post-process materials and getting a cool stylized look.
All right. Sounds good.
All right.
Do it.
Dive in.
All right. So I think a common question I hear is how to do cell shading and kind of non-realistic look in Unreal 4. Unreal Engine 4 uses PBR shader, and it strives to get a very realistic, rich look, but oftentimes that's not what you want. So what is toon shading? Toon shading is a combination of an outline shader and a cell shader. And you combine those together, and it looks kind of like a cartoon. So it's
Or
a way of
simulating
simulating
like a comic
hand-drawn
book
look.
or something
Right.
like that. You know, ink and paint, you've got a posterized color, and then I've got a really thick, defined outline that, you know, shapes everything up and gives it a little volume and things
Right.
like that.
Kind of avoiding soft gradients and
Yep.
making it look more illustrated. So there's a bunch of different ways that we can achieve these looks. Some of them more complicated than others. The most common one that's been used in the past is the inverted hulls. You take a mesh and you flip it inside out, and you color that mesh black, and you overlay it, and it creates an outline. It's really easy to do. You do it in your art package. It gives you a lot of flexibility because it's just part of your art pipeline. But it's hard to tweak, doesn't look good on a lot of models, doesn't deform very well for skeletal meshes, and it's fully on the art side. You know, the tech artists and all of us as engine people can't really do much with it. But it works on mobile. It works pretty much on anything because it's just the way the mesh is made. So I'll give a quick demo of how to do that here. See if I can get Max up.
Hey,
So here's our cow model. And he doesn't come in with textures, unfortunately, because he's using a mask. So we'll just pretend like he's got a face. So this mesh, the first thing I'm going to do is turn on the back face cull. By default, Max likes to display the inside and outside faces, and that's not going to work for us. So we simply duplicate this guy, or clone him as they call it in Max. And then a couple of modifiers. We just take this guy and we put a normal modifier on him.
So with the normal, we're just going to
flip the
Yep.
normals there, which of course we can't see because the other toy cow is there. But now, oh
my God, what'd you do to
inverted
them?
cow. It's horrible. And then we're going to put a push on there.
It's a beef-tastrophe.
And push takes the normals, each vert, and pushes it in and out based on its normal. So, you know, if I do it extreme, it's really horrible. But we can just push it out just a little bit this way. And
So why do you want to push the flipped one back out?
So, let me get this guy back on. And the push, what that does, and I can just toggle this in and out, is it gives us the outline. Okay. So now, of course, we also have to go in and take that outline guy and put a different material on him. Let's just go ahead and make it a black black material since most outlines are black. I'll throw that on there, and voila. See, we have
Hey.
an outline. I've forgotten how to use Max's viewport controls because I've been in UE4 for too long.
Press P real quick. There you go. Now
There we
you're
go.
in
Now I
perspective.
can-
You were in a camera before.
Oh, that's why. That would explain all of my problems here. So yeah, you can see you get a pretty good outline effect.
Yeah, it looks really good.
You know, you get some errors in corners and stuff. Another issue with this one is as your object gets further away, the outlines disappear. So if you wanted to have an exactly 1 pixel outline for everything, it's going to be hard to achieve. And of course, when you get close, your outlines are going to get bigger. But like I said, this will work on any platform, and you get outlines basically for free. Hey, that's the demo I just did. So that's the most simple way, and the most complicated way would be to write a custom shader in the engine using USF, going and being really complicated. We're not going to do that today.
All right.
This would be something if you were doing something that required absolute highest performance, or you had a very large project that you wanted to implement this on a very basic level. You'd go
So if you were
and-
applying it to like your whole game or
If
something
your
like that,
game
would
was
it be?
based off of cell shading, then I would do the USF approach, because
Okay.
that way you're going to get a native implementation, because you can do a combination of call between USF and C++, so that's going to give you something that's wickedly fast.
Right.
Especially when you get into stuff like the SOPL edge detection and running all of that per frame, and then running everything else on top of that is just, it's going to end up eating processing power. So implementing something like that, if that's what your game requires, if this is just like he goes to the dream sequence, and the dream sequence happens to be in, you know, this posterized looking, you know, world, then setting it up like a post-process or doing that simple toon shading where we flip the holes around is a better approach, because
Right.
it offers a little more flexibility.
And also those other techniques can be used as a prototype. And then if you get to the point where, you know, your game needs that extra 1.2 milliseconds that are getting eaten up by the post-process, you can go this route too. You can also modify the entire shader pipeline that way to solve some of the kind of edge issues. We're going to be looking at using post-process mostly. We're going to take a look at the post-process material pipeline and how that works in Unreal.
There's a window on
Oh, yeah. Is that me?
the... No,
No.
I think that's over there.
I think
You,
it's a sound.
you don't see that, don't worry.
Okay. So post-process gives us, it's a medium tech. It's not high tech. It's not low tech. You need some skills. You need to know how to use the material editor. All of it's done in UE4, so you can tweak it in the editor a lot. It's very flexible. And it has a really predictable performance cost. The flipped hole method, for example, if you have a very high polygon model, you're doubling the polygons. So scene by scene and frame by frame, you can have very different performance issues because of that. Whereas post-process is a fixed performance cost per pixel. So of course, as your resolution goes up, it'll cost more, just like most things. But it's very predictable once you implement it. You know that that's what it's going to do. It's not low tech, so you do have to have someone write a shader and maintain a material and everything. And then in VR and mobile, there are some limitations because we'll be relying very heavily on the G buffers, which are part of the deferred rendering process. And the G buffers give us information like the scene normals and the depth and the base color and some other things. VR and mobile, depending on the platform or if you're using forward rendering, might not have access to those, so you're limited and you have to find some more workarounds. So how to do this? Really, it's called a Sobel operation. Sobel is just really comparing one pixel to its neighboring pixels and finding out what the difference is. So if there isn't much of a difference, you don't get a very big number, but if there's a big difference, you get a big number. And so you can just throw that in and it creates lines. And we'll see that in a minute. We'll get into the editor. So this is a diagram showing, you can see our center pixel here, which is the pixel that renders. And then we're going to ask each of these 4 pixels for their values too. And we're going to ask for their depth value, find out how far from the camera they are. And then we're also going to ask their surface normal. And we're going to compare those. So if there's the greater the difference, the brighter the line will be, or the brighter the pixel will be. So let's see how that works. Not there. Here we go. So here we are in Unreal with a nice little scene I've made from the example content. I love the cow too. I like this little spaceship too. And the conceit of the spaceship picking up the cows. So let's get started here. The first thing we're going to need to do is drop a post-process volume into our scene. We already have one. It's our global post-process. It's handling the bloom and the look and the color grading. And I'm going to drop this one in, which will add on to that. So I'm going to first check on the infinite extents or the unbound. Make sure it's enabled. And now I have a place to drop a post-process material. So in the rendering features, in the details of the post-process volume, you'll find this post-process materials array. You can have as many as you want. Of course, each one will add its performance cost. So we added one to the array, and then you can choose between a light propagation volume, which we won't get into, and an asset reference, which we will. An asset reference is just that. It's just like a reference to any other material or asset in the editor. So now we have a place to put our material. Let's make a material. So a post-process material is just like any material in UE4. It's made with materials in the material editor, and we'll call this toon shader. There we go. I'll drag this over so we can see it here. So to get a material to be a post-process material and access the gbuffer, we just set the material domain into post-process. You'll see right away that the only input we get is emissive color, and that's all you can pipe through. So if I were to take this guy and, of course, apply, and hey, I don't need that. I don't need that. I don't want that. And put that into this post-process material array, you'll see everything turns black, unfortunately, which shouldn't be unexpected since nothing's in the emissive color. So, of course, we could pump in a vector and make the whole thing one color. Our whole scene is red, pink. Not terribly interesting. So let's get to get the actual scene to come through, because we'll want to add stuff to it, we use the scene texture node right here. And in the scene texture node, in the details, we've got a list of where our source for our scene texture. And normally in a regular material, you would use scene color to access the scene color of the pixels behind the translucent object. But in post-process, we have to use post-process input 0. And that just means it's the pass-through scene texture that goes into the post-process pipeline. And if we connect that to the emissive color and hit OK, it'll be equally unimpressive. Oh, I just love it. Just really want it to do that each time. You can see it's our scene. So we are just passing the scene right through. So now our material, we've got our scene. We can start to modify our scene and add stuff to it. We can tint it, we can distort it. But what we're going to want to do is start to pull some of the buffer data and do that Sobel operation and get the pixels. So our first one's going to be the depth, the scene depth. And so instead of our post-process input 0, we're going to look for scene depth. Easy enough. And if I hit this now, it would just totally bloom out because, you know, these are all very, very high numbers. The scene depth I can quickly divide by 500 and put a div or frac. This will just help us visualize this.
So what he's basically doing is he's going to make some stair steps to kind of give us a little bit more information in the world.
So yeah, exactly that. So the frac just it kind of makes it loop. So once it hits 1.01, it removes the integer from it. So you're always between 1 and 0. So it'll create banding, but as you get further, you can see it does that. Ooh, cool. So that's a very basic example of using that data to then push it to the scene and be able to render that. You could use that to create fog or something like that. So we're not gonna need to do that, but we are gonna need to sample. So this returns that center pixel, the 0, 0 pixel from that diagram from before, and we need to sample the one above, below, left, and right. So to do that, we have to modify the UV coordinates going in here. And we want to do it by exactly a pixel. And there's some math involved here. So don't get scared because there's a cheat. You used to have to do like 1 divide by the scene size and whatever. But then some smart graphics engineer put this little node here for us all to use. And this is the inverted size of the scene pixel, which just gives you the fractional size of a pixel so that you can pull it out, and we will multiply against a 2 vector, and then add to our texture coordinate. So a texture coordinate in a post-process is really just the pixel that it's at on the screen, from 0 to 1, 0 to 1. Just like a texture map would be, except your texture quad is the rendered scene.
Is it still, instead of it starting in, like, what is it, the upper left-hand corner, does it start in the center?
No, I believe it starts in the upper
Okay.
left-hand corner. I think. Why do you have to ask me that kind of question, man? That's HLSL. But I'm not even going to get into that. So we've got our texture corner, so that'll be our center pixel. And so we just want to simply add to there. So now we're not adding anything. So we need to do, so we are now going to look just to the right, to 1 pixel to the right. And then this is, well, I'm going to name this because otherwise I'll keep losing it. Center pixel. And so this is the right pixel because it is 1 over on the X. So this is our right. Just call it right. Hit the enter. And then we can take the value of this, which we'll have to mask out because we only want the grayscale value of this. We don't need RGB for this. And in fact, it can cause some errors because this will return the RGBA, which is too much for most math things in Unreal. So we will take our right pixel and subtract that, or I should say we will take the depth value of the pixel to the right and subtract that from our center pixel. And we should actually, from just this, get some edging.
Nice.
So you can already see some lines starting to develop in places, and of course some gradients because we're only going in one direction here. So it catches gradients going to the left and lines going to the right.
Some 1950s, like, kind of sci-fi-esque.
Totally. You can actually kind of do fake lighting in post-process by doing this sort of thing. Of course, you got to be all sorts of fancy to get shadows. And so we need to do this 4 times. Thankfully, we've got copy-paste. So I'm just going to take this whole thing. I'm going to copy it up here. And I'm just going to change this guy to be our left pixel. So it's -1. Rename him left. These are just labels. These don't do anything. They're just so I can see it, and when I come back, I know which one I'm looking at. So again, we're going to subtract, our center pixel value with our left pixel, and then we add these two guys together. Now we should get even more lines. Oh, look at that.
That's fancy.
So let's just do that for our other two. I'll just take the whole thing. We'll just copy that guy down there. Same thing, we'll do 0, 1, and that'll be the down, and then 0, -1, and that'll be our up pixel. And then we just need to throw in these center pixel value into each of these subtracts. And then let's add our add. So we've got the left and right, the X value and the Y's, and they combine, and then we need to combine each of them. So we'll just add them all together. Add, add, add. Now, if everything went right, we've got lines.
Lots and lots of lines.
Lots
Very
and lots
cool.
of lines. So this is the most straightforward way of getting your lines. And I'm going to take a little quick moment to make an adjustment. You can see we're getting a lot of jitter. Everything's dancing all over. Unreal uses temporal anti-aliasing, which you can see it in action here. It literally just shakes the screen around constantly and then averages those values to smooth out pixels. And it looks beautiful and gives it a great look. But when we're doing stuff like this, it becomes really visible.
Except for when we're doing
Post-process lines. But we can fix this. So the post-process material can take place at several points during the rendering pipeline. We'll come on down here to the post-process material. So the default is after tone mapping. So that's after bloom and ambient occlusion and everything else in the post. It's the very last step. So it'll take your raw, fully, not raw, your fully HDR scene and use that. So if you want your blooms and stuff to be affected, that's where you would want it. There's also before tone mapping and before translucency. And really, both of these happen before tone mapping, which is before all those effects. And you can decide whether you want to include translucency in the process or not. If you do before translucency, the translucency will be layered on top of your effect. If you do before tone mapping, the post-process material will run after the translucency has been added, so it will affect the translucency. Does that make sense?
Yep, that
okay.
makes sense.
So we are going to do either one. In this case, I'm just going to go before tone mapping. And you'll see right away, not only are our lines less jittery, they're also thicker. And this is because as it does that jitter, that one pixel kind of exists in a few places, so everything just gets a little thicker.
So it could be pixels up here, it could be down here a little bit. You're getting the average of where all the pixels are.
Right.
So
And
it's
these
gonna be
lines
a
are pretty
little bit of a
bright,
thinner line.
so they show up really well, and they kind of catch in all those pixels. So we probably don't want our, I'll just keep doing it, Windows. We probably don't want such thick lines. So we can do a simple image manipulation to these lines by adding a multiply and a power, basically, so that we can control the contrast and brightness of the lines.
Okay.
So if we just run a multiply, and I'm holding down S and clicking to create a scalar, which I'll bring this over so we can
Good
see.
job explaining what you're doing instead of just clicking and putting stuff down and keep on going.
Magic. And we will call this depth line. What did I put in there? Depth line.
That looks like line.
Multi-suite. You're slightly closer. And we'll default this 1 to 1. And then we'll put a power on here. And I'm thinking I might have these backwards. I can never quite remember if it's multiply first or power. And again, default value, and we'll call this depth line bias. And then we will, here's another good trick. So you can take a node and right click and just connect straight to emissive rather than having to drag up each time. And that's really helpful when doing these post-process materials because you can just
See how
go to
wild
each one.
It can get really, really,
It
really
can
big.
get really big, really quick.
fast.
And so now we can modify these guys. I'm going to then move over here so we can modify. I think I'm on the bias. Is it modifying? Oh, yeah. So if we lower the weight or the multiply, you can see we start to get rid of a lot of those extra lines.
Getting rid of like the interior lines.
Those interior lines and all this extra stuff out here. That's probably...
Showed it really well on that fence post right there. If you put it back to the setting of 1, I do believe.
1?
Yeah, so you
So
can
yeah,
see
you can see the edge
you
lines
see the
here.
edge right there.
And that's just because the depth there has a little bit of a bump due to the edges. It's amazing how much detail you can, especially on round objects, you can see, like this guy here, he looks...
Looks like he got cut up a little bit.
Yeah, a little bit. And the hill back there, it's just not quite the look we're looking for. So we can go with like 0.1 and then add a little bias. We'll see if this is in the right spot. It seems to be.
Yeah, it looks like it's in a good spot.
So now that's pretty good. And that's actually a really nice outline
yeah,
shader.
Looks really good.
It's got some issues that I don't like. One of them being that it doesn't have the inside lines. You know, I can't see any of the detail in here. I can't see the cow's eyes or his face or where this meets the ground. And those are really key lines. So the depth gives us stuff that's far away from other things, which is important. That's, you know that it's another object and you would draw a line there. So the other thing we can do is, to get those inside lines, instead of comparing the depth, we can compare the normals. Because let's say the fence post is looking straight at you. If you sampled this pixel and then sample the one on this side, we'll see a pretty big difference. If we just sampled the depth, we wouldn't see a big difference because those 2 pixels on that corner are super close, but their angles are very different. So we can find some information that way. So again, I'm just going to take this big, messy beast, just drag it a little bit because I'm sure some people are screaming at my spaghetti.
They were a little bit. They were trying to reach out, and they're like, "Can I
Please,
just massage that
can I
into
just
place?"
arrange that? These could all be coming off of one node. And yeah, this network is a little spaghetti-ish. I would normally do things a little cleaner, but I just want to make it really clear. Yeah, lots of constants and.
No, I said add some comments.
Oh yes. Well, I'm going to do a comment right now. This is going to be
Oh,
called
he shot me down.
depth lines. So I did that by selecting them all and hitting the C key, and it makes a comment box. So I'm going to take all of the depth lines, copy, paste, boof. We're going to call this normal lines. So this only takes a couple of adjustments. The first thing we obviously have to do is go through all of these guys. Go through these guys and switch them to the scene normal or
So,
the
and he was
world normal.
Just holding down control, and he clicked every single one in the node. And since it's all the exact same node, he's able to mass edit everything at once, just in case anybody was wondering what he was doing there.
I can find
Which one are you looking for?
world normal.
That's ambient occlusion.
World normal.
There you go, right there.
Is there in alphabetical order or not?
Because, you know, that's how words work.
So now we're sampling the world normal. We don't just want the grayscale. And I'll show you here if I just connect to emissive color, show real quick. it's not all the information we need. A normal is a vector, so it's a 3-value XYZ. And this is more what we want. So we need to compare the XYZ, so I have to adjust these masks. Select all of them same way, holding down Control and selecting them and modifying them all at once. So now we're doing the same thing. We're taking that center pixel and we're subtracting them out, and we're combining, add. And I think if I go right here, I'm going to go to connect to emissive color. Look at that.
Hey,
now we have our normal lines, and you can see they're colored based on the normals. And so the normal lines almost do the opposite. You can often lose the outside edges, like right here, because this normal is the same as the ground. They both face straight up. So you're not going to get that nice thick line. Like right here, you can see it really well. And so they work well together.
But those aren't the ones we want, right? We want the actual interior lines.
Right. So now we can see the cow's eyes. We can see these inside edges
His
of
nostrils.
the post. He has nostrils. Of course, we've got some of the same issues with the biasing and the multiply, but that's easy enough to take care of. And we also want to get rid of the color. We just want it to be white. And there's a nice node that I discovered, which is add components. And this takes a vector and just adds the components together. So we have a float 3, so I've moved it from the float 2 to the float 3, and I'll output out to the float 3, and we should see it all turn black and white. So we've just added each of those channels and returned a single grayscale value. The other thing I need to do is change the name of these. Normal lines multi. Normal lines bias. And we can connect these to the emissive color.
Cool.
And there's our lines. And of course, I think they've been a little overly biased. Maybe I'm just biased. There's a joke there. And
Are we doing do-it-yourself jokes?
yes.
I've provided you some funny words. You put them together yourself.
So then we need to combine these two so that we get depth and normals. And the way you can add them together, but you might get, a lot because it'll add past one. You can clamp them and then add them and then whatever. I finally settled on a max node. So a max node will take whatever the highest value. If you pass it 2 pixels, it'll take whatever the biggest one is. So it'll just always take the brightest. So it's kind of like a overlay mode. Not quite sure what that would be in Photoshop. I missed. That's why I do this. Connect to emissive. Now you see we got inside lines, we got outside lines. We have some extra lines out here, but of course we can tweak those, and you'll see in a second when we make those into black lines, and most of that will disappear. So let's get the lines onto our scene instead of this mask. So this is our mask, our line mask. We can say stuff that's white will be lines and stuff that's black will be scene. And to do that, we need, once again, one of our scene textures, because we need to sample the scene texture. And that, again, is the post-process input 0. And just as an aside, if you were to leave it on scene color and tried to do that, it would give you an error and let you know scene color lookups are only available in surface domain. You must use post-process input 0. So if you do it wrong, it'll tell you what to do. And your error disappears. So we want to take this guy, and I am going to lerp, it's one of my favorite nodes, the linear interpolate. Linear interpolate takes 2 inputs and then takes an alpha and blends between them. So you can pass it pretty much anything into these guys. You can pass it textures and
Lerp is like your material editor, crutch. Pretty much use it for everything.
Pretty much. It's super great. And so we're going to use the lines that we made as our alpha. Before I do, I know that I need to clamp this because the lerp doesn't clamp, and values over 1 will just, you know, it'll just keep multiplying and multiplying, and values under 1 will keep going. So we've got to clamp these lines because they're probably really bright, but we don't know it. And we're going to combine. So the A input is the black in our image here. So we're going to, all the stuff that's black should be the scene, and all the stuff that's white in our mask will be black here. And I'm actually going to make a vector and call it line color because I like to be add a little flexibility, and there's an empty node here that's just, I found an error. And this is a common one when working in post-processing. You will see this error of float 3 and float 4 not defined. And I hit on it really briefly earlier with these masks. The post-process, or the scene texture, returns a vector 4 out of here, and most colors are a vector 3, so it can cause some errors. So we just go and put a mask.
And what he means by that is it's going to return the RGB and the alpha,
which would be this.
Yeah, and normally that's disabled because you don't use the alpha very much. We can save an extra channel. That's going to be saving us some performance.
See, our error disappears just with that little mask. So if you're getting that error, you probably need to put a component mask on your scene texture. And here we go.
Hey,
We zoom on in.
see some outlines.
There's some outlines.
Not super sharp,
Let's make it.
but I think we're going to fix that.
There we go. So I also want to hit on, of course, as we move into the next part of this, which is the cel shading part, is that source art is a huge part of this still. You can't just take any content and throw a cel shader on and it's going to look good. If your textures have a lot of noise and a lot of normals in them, you're going to get a lot of noise and it's not going to look good. You need basic shapes and basic colors, and so there is an art pipeline. It's not just a magic make your game look like a cartoon, which is why I'm using these cartoony-ish assets. You know, I tried it in some of the more realistic ones, and it looks cool, but it wasn't really the look I was going for, because I really want to get a cartoon look. So we've got our lines, and you know, we could go in and tweak them. Feel like the inside lines need a little oomph. There we go. Now our inside, so we can see around his eye and everything a lot better. Looks pretty good. Of course, if you wanted to make your lines thicker, you could go in and modify these and push them out
Pull it over
further.
so they can see what you're talking about.
Yeah, that's on the other monitor.
There you go.
If you wanted to make your lines thicker, you would simply sample another pixel out in each direction. So you could modify each one of these vector values.
So instead of using 1, you would just use -2 and 2.
And to note, you have to use an integer.
So you couldn't do 1.5.
You can't do 1.5, unfortunately. There's no pixel there, and
That makes sense.
the G buffer can't return a filtered pixel, unfortunately. So you just get kind of noise, and it doesn't quite work. Maybe one day. So yeah, so that's our lines. So let me return to this guy here, demo. So now we've got our lines. Now we want to, you know, right now everything in here has nice gradients and shiny reflections, and it doesn't really look toon shaded. People might not even notice that it has outlines yet. So let's add that. What the? Here we are. How do we add that? So there's a couple ways to go along with the hull, where we duplicated the cow and flipped his normals to create a shell. You can also create a cel-shaded look through the object's materials. You can paint things to look totally 3D. You can even do some nifty math with vectors and create banded looks in there. But again, it's a per object thing. It's a per material thing. It might be hard to maintain through an entire big project, but it'll give you a lot of fine control. But I wouldn't say that it's an easier way to go about it. It really depends on what your goals are. If you really need a perfect, cartoon look that matches, the TV show cartoon, you're probably looking at a USF thing anyways. And, this is kind of an old school way of doing it. I'm not even going to demonstrate it because I don't think many people will be doing it that way. It also doesn't have a lot of access to the scene lighting data, so you'll be kind of overwriting all the nifty PBR and shading stuff that Unreal is doing.
Sounds like you're going to kind of be fighting Unreal a little bit.
You're kind of fighting Unreal. Unreal will still be running its full renderer in the background, full PBR, and you'll just be covering it up. So maybe not the right way, but it could be the right way for your game, or if you just need an object that needs it. So we're going to look, of course, at the post-process. So a lot of the same pros as before, same performance profile. It's global. It covers your whole scene. It's easy to tweak because it's in UE4. We also can get the lighting and shadows because we're dealing with the actual rendered scene. Cons, it can look bad. Posterization, you don't have a lot of control over what colors are being presented. So you have to control your lighting and your materials and everything much more deftly to avoid kind of colors you don't want. If you don't want that weird pink band, you're going to have to go in and make everything.
Like fine-tune it.
Fine-tune it. Again, it can't just like throw it at the Showdown demo and have a cartoon version of it. And it requires art support, asterisks, because you do have to kind of design your art pipeline and your look to support it so that it looks its best. The assets I'm using, of course, are straight out of the content browser or the content examples.
Yep.
So they weren't authored for that, so they have some of those issues, but they will still look pretty good. And fortunately, this is actually a very easy thing to do. Posterization is like HLSL 1.0. It's like the first thing they teach you on NVIDIA's website. It's just a couple of math nodes, and we're going to take that and combine it with a little trick I figured out to make it look a little more toony, and we'll see why we're going to have to do that. So I'm going to move this guy over, give us some room. And I'm going to start posterizing. So I'm going to take our scene texture here because I want to posterize it. I'm going to bring him down here. Just going to make this bigger so we can all see what I'm doing. Might as well get rid of this guy too. All right, so we've got our scene texture, and to posterize, all we're going to do is, and now I have to remember the order of operations here, we're going to multiply it by a certain amount, and then we are going to floor. Floor is like a round. It rounds down. So if you've got 1.6, you get 1. If you've got 2.2, you get 2. So it just rounds down. There's also a ceiling, which rounds up, and I think there's a round now.
I think there is a round, actually.
But there wasn't for a while, but now there is. But we're going to use floor. You could use any one. It'll slightly change the way it looks. And then we are going to divide that by a single amount. And we are going to call this number of colors. And it's really not the number of colors, but it is the number of bands that you'll get through each color range. And we'll connect this guy, and we're going to add more than 0 here just so we get something right away. We're going to hit apply.
Cool.
Look at that. So now we've got that posterization. So we've really just kind of expanded the image out really far and then averaged out all of those colors and then shrunk them back into the view space, if that makes any sense. So the go over here. The more colors that we ask for, the more bands we'll get, up until the image just looks smooth again. So we can go all the way down.
It's almost like you're making the sunset.
Right? Oh. Da-da-da.
It's nighttime. Daytime.
So really, the value of this is up to you, where you want things. But you'll see right away that we end up with a lot of black. And that's just kind of par for the course for how this works. If you've got any contrast in your scene, you're going to end up with a lot of black. So I fought it and I fought it. I just couldn't get it to look right until I kind of accidentally discovered, oh, you can see, base color is the unshaded colors. So it's all the,
So
it's just the,
all your obetos.
right? It's the base color from each of your materials. And I'm like, well, that looks like a cartoon. What would happen if I overlaid this on top of it?
You're good. Sorry.
Oh. Ah, remember the mask.
Ah.
When you see the, oh. Yeah, there we go. So now we've got,
Hold on just a sec. The Twitch is
uh-oh.
gone.
Am I live to anywhere?
Our Twitch folks are having issues.
I'm sorry, everybody.
What did he discover?
What did I break?
I have that Twitch stuff.
Do y'all still hear us on
my phone?
YouTube?
And it's like, one of them's like, the stream ended right exactly before he explained what I wanted to know.
Of course.
Yeah. Sorry, folks. Just 1 second.
Put up the technical difficulty signs, like the puppy playing with the cord. The one from The Simpsons.
Yeah.
Um,
Do we have that?
1 sec. All right, we're back up on Twitch. Sorry about that, folks.
It's cold out here.
All right.
I don't know. Twitch is being grumpy.
Am I live again?
You are.
Yay, I'm alive. All right. Well, I'm not quite sure where Twitch cut out there.
I think
so I should go
I
back
think
a little
it
bit.
probably cut out when you were started over where everything was black.
All right. So yeah, let me.
Let's see if
Hopefully
Yeah,
this is
they're
where I
asking
was.
how did you solve the excessive black?
All right. So
okay, yeah.
to solve the excessive black, thank you, community. And you can see I've done it here. So yeah, I took. I'll just go back. So I was digging through trying to figure out a nice toon look, and I was playing with the scene textures and just going through each one of these, seeing what they are. And I hit base color, and base color returns the base color of all your materials with no shading. So this is before any lighting has been applied. And you can see it looks like a cartoon. So I'm like, well, that's a good start. Now if I could just get that lighting on top of it. And that's super easy. Lighting is really just an additive process. So let's take that lighting that we had and add that. Here's our scene with our posterization, and we'll just add that to the base texture and pipe that in there and apply.
Cool.
And here we go. So now you can see we've got some nice color banding. We don't have a lot of strong smooth gradients and stuff. Maybe the background's a little too bright. That's really easy to fix. I just threw a multiply, and I'm holding down V and clicking to get a vector parameter, which I will name tint. And I'll multiply that, and then send that into that add operation. And now we're back to black. But I can edit this guy and bring in, I could even like bring in a little bit of blue.
Cool.
And create
That's
a
nice.
nice look. So yeah, with just a couple nodes, you've got a pretty okay. And this is nice because it's using the full scene renderer, so you still get reflections and shadows and lights and all of that stuff. The full Unreal pipeline is being used and modified.
So it gives you the toon look with all the flexibility of the renderer.
Right, right. So yeah, you'll get toon shading on reflections and stuff that you may not want, but you may want it. So it's really up to you artistically. So let's go ahead and add our lines back on here, and we're pretty much done. So to do that, we're going to use another lerp, because I love lerp, and I hold down L, and I click to make a lerp, one of many chords. And so one of these, the black is going to be the scene, while the white, the black is the scene, while the white is, you know what, I already have this set up, don't I? So really, I just need to take this little thing I have here. So we've got our lines coming in, combining, and getting clamped to 0 to 1 so that we don't have any negative data or any like super crazy. Got our line color. And then this is our scene. So instead of our regular unprocessed scene, we will go and take this guy and replace it. Whoop. Then we'll connect that to a emissive color. And I'm going to run clean up to get rid of these guys. Look at that spaghetti somewhere, someone's screaming. And we're going to hit apply. Cool. Here we go.
That's looking pretty sweet.
Just like that. And 60 minutes later, you've got a toon shader in UE4. So there's the one last thing I did was I was like, this looks too flat now. It's just too flat. It's got no depth. I can't, there's no contact shadows. I need to bring back some of that depth. So again, I was playing with this, the scene lighting, or the scene texture, and I copied this again. And I discovered, oh look, I have access to ambient occlusion. So of course I can just take ambient occlusion and multiply that on top of everything. And now I'll get the, man, I did it again.
Wah, wah, wah.
It's almost like every time I do this, I have to make this mistake.
Never learn.
Never learn. I never will. I refuse, Dad. You might not be able to see it because it hasn't been tweaked, but now we've got some shading and a little bit of roundness around our characters. Let's see if I can learn how to use this keyboard. And find our post-process. And we will go and add some ambient occlusion. Crank it.
Oh, very
So
nice.
now you can see that that exists right on there. Just adds a little extra, and you know, of course, you probably tweak it to not look so absolutely terrible in your own projects. But just wanted to give it as an example of some of you can continue to add and create some of your
Start
own effects.
injecting back, you know, maybe you mess with the roughness or the metallic or something
Right.
like that. Something that's going to give you the look that you want to go for your project.
Right, and it's fun to just go through the scene texture node, and you have access to all of this stuff. So you can do a lot of really fun masking and you can make everything with a metallic property do something. It's really, really an interesting way of experimenting with post-process, just to kind of see what's in here, because it gives you access to a lot of fun stuff. Yeah, so I think I've got some other slides here real quick. Let me see. Add screen space ambient occlusion. We've talked about the limitations of doing this briefly. VR and forward rendering. I've tried it. Obviously, posterization works, but you don't have access to that base color map. So you can't do that add-on. So you have to find some way of getting rid of those really deep blacks. You also don't have access to the normal G buffer. You only have access to the depth and the base color. So you can get the outlines, but you can't get those inside outlines.
I see.
So there's some trade-offs there.
They're also wondering about some performance too. Like, how does it affect performance in VR versus?
It's pretty low
Okay.
performance. It doesn't do a whole lot of math operations and mostly just accesses what's available already in the rendering pipeline.
But again, this is going to be something that if you are using this for VR, it's going to be something you're going to need to pull up the profiler, check it out,
Right.
make sure that you're within your budgets, and then you're going to want to crank down on things that you don't use. So say, for example, you don't use any metallic. Maybe you want to pull out. Metallic's not the best example. Let's say from your post-process, you don't end up using maybe some depth of field or something else like that. So you're going to want to crank that stuff down so that you then have a little bit of extra processing power for the toon shading or things like this. And then use a combination of stuff. Maybe you set it on a distance base. So from 0 to, say, 1,000 Unreal units out, you have the post-process material. Then anything past that uses the first trick that you showed us with just flipping the normal. So you get this very, very cheap mesh-based effect. It's coming up with little trade-offs like that, which is going to affect performance more than anything else. But also, a lot of this is unlit stuff, so really, really, really cheap.
Gotcha. Are you showing that?
Post-processing. So this shader at 1900 by 1080 is 0.27 milliseconds.
That's very, very cheap.
So it's pretty darn cheap. Of course, it scales up pretty linearly with your resolution, so you're going to get twice as much as that.
Yeah, I was going to say in VR, yeah, it would be about
twice.
Yeah, about twice. Because
You
you got to
got
render it.
2 of those.
Yeah.
Give or take. There's probably some optimizations there, so it might not be. But I would count on it being about twice that much for VR. And 0.5, 0.6 milliseconds in VR is
I'm actually
significant.
reading all of your questions.
On desktop.
Someone
not
was
so
asking
much.
me about, they're like looking at his phone. I'm reading the questions because I don't have my laptop on me.
Yeah.
Sam's he's easily distracted.
That is true as well.
We have to keep him supplied with video games and memes at all times. So yeah, any other questions?
They have some. Could you do a variable thickness? So a lot of this is pretty straightforward, but they were talking about, for instance, like Okami has a variable thickness around a lot of the assets or the items in the scene.
You could, yeah. Like I said, you can. So right now we're sampling just 1 pixel over. You could sample 2 pixels to the right and get kind of a bias. You could sample 2 pixels everywhere and get a much thicker line. You could have a different thickness for the normal-based lines, so your inside lines are finer and your depth-based lines
But
are
are those still going to
thicker.
be uniform, like left to right, as opposed to like a brushstroke kind of shape or something like that?
Yes-ish, unless you do that like offset where you're sampling more in one direction.
Okay.
But not so. I'm not sure how Okami managed theirs. I think it's a combination of particle systems along with post-processing to get that effect to work right.
More ink and paint kind of technique.
Right, and that's something that you would need to probably dig into the USF to create something that could, stretch an image along kind of a vector path or something.
Right. Can you smooth out the line between colors to make it look like it was done more with markers, or is that going to again be more like a USF?
Yeah, I mean, you might be able to, but just thinking about it, sounds like a blur operation. In that case, you might be better off, it sounds like for the gradients, you might just be better off kind of, if you were to take this technique, let me try and pull up our material editor. And where is my posterized scene? So if we were like to crank the number of colors here so that it's not really posterized anymore, you know, this is a more toon-like look because we're adding it onto that base color. It's kind of washing out all the shadows.
yeah.
So you could get something like that, but it would require some art direction. So here we've got, you know, a much softer, more gradient look. Kind of looks like marker. So yeah, I'll say yes, you can. You just modify this. See?
Let's see. And they kind of assume you can make this a material instance and edit it in real time, so
Correct.
that.
And that's one of the great benefits is that uses the Unreal material pipeline. It's just a material. So material instances work, parameters, switches. You can also have, because it's a material and it's based on these post-process volumes, you could have it change values as you move from one place to another. So one place might not have any outlining, another place does, or you know, one place has more banding and one place is smoother. So, and it'll actually interpolate between those as you move between the volumes and the different settings in your instances.
Okay. Let's see. Would it be possible to make the outlines the same color as the mesh, but darker? So can you sample like the color in the scene that it's on?
You can, yeah. So you could, so right now we've just got a color, or our line color somewhere. Here's our line color. So if you wanted to, rather than the line color, you could probably just take this base color. Let's give it a try. Oh man, one day I will remember to mask that. One day. And then they'll fix it so I don't have to.
It'd be nice if you just like, do you want alpha
Right.
on the node?
Like right in there?
Yeah.
Yeah, wouldn't that be nice? All right, so yeah, here you can see like our lines here are now based on the mesh. We've got white lines on our cow, and now a yellow line around him. But you can see his white lines. It's pink in here. We've got green on the trees.
You can see it really good on the side of his mouth over there.
Yeah,
Yeah, right there.
right there. So yeah, you've got his white line there, his white lines around here. You could, and then of course tint that as well, so your lines were maybe a shade darker than whatever they were sampled from.
Nice. Let's see.
Woohoo, it worked.
Close one. They're wondering, would this work on particles and voxels as well?
It'll work on anything in the scene.
Okay.
So I think this guy's got, oh look, he's got some particles off his bow. Port? I don't know why I'm using nautical terms. I don't even know them. And you can see right here, his effects are getting posterized. So if we didn't want that, if we wanted the translucent particles and stuff to not be affected, to sit over it, we can change where this blends.
Yeah, that
right
was actually
here.
one of the other questions, is about excluding things from the effect and how to...
And so that's a good way of doing translucent objects to get them so that they're not, which will be most of your effects, you know, fire and whatnot. You'll probably, typically you want those to not be affected. They're kind of unpredictable with all the other colors.
Right.
And then you can use, if you want to just limit the effect to individual objects, you can use the custom depth buffer and mask out this effect so that you're only getting it on things or not on specific things.
All right. Well, I think that's about all of our time for today.
All right.
Wanted to thank you both again for joining us. Also, if you have additional questions, feel free to jump back into the forum post where we made the announcement, and I'll send that link over to you all if you're willing to answer your questions,
Certainly.
and we can follow up to some of the things that we weren't able to get answered today for you. As always, please submit your projects to the NVIDIA Edge program. We're always looking to give you amazing 1080 Ti, so, you know, you make awesome projects, and I'll give you some sick hardware. You can't argue with that, right? I also dropped a link into the chats about our live stream survey. let us know how we're doing, what topics you'd like to see in the future, and then we can keep doing more of these streams.
Yeah, she just
that are
tells us
for you.
like, will any of you do this topic? Here's a list. Pick from the list.
This is what they want. This is
Welcome
what the
to
people
Epic. Want to be on TV?
Yes. But again, thank you both so much for joining. This is a very useful thing for our community, and we really appreciate all your help and
Well, I hope
knowledge.
you guys enjoyed it.
Thanks for having me.
All right. Thank you all. Have a good week. Next week, we are going to be talking about copyright and trademark because it's an important thing. So
Very important.
we'll see you all next week.
Bye-bye.
See you, everybody.
Bye.